Assalamualaikum and good day. Today we are going to continue our lecture on Module 11, Switch Security Configuration. Okay, on this module, we have several security issues that we would like to highlight to you. First, we would like to implement port security on our switch, and then to mitigate VLAN attack. Okay, for the port security, we are going to prevent unauthorized user from connecting to our switch, from use the switch as their networking device. And then for mitigate VLAN attack, we are going to secure our trunking protocol. So we would like to prevent from other switch in order to recreate another trunking protocol by introducing a root switch. Next is the mitigate DHCP attack. Actually, we already take a look on the DHCP implementation. There is an issue with the, remember DORA, discovery, offer, and request, and lastly acknowledge. So in the discovery, a client might request a multiple entry. So they might send like 1,000 of requests. So our DHCP might be exhausted. So we can prevent them by introducing DHCP snooping. Actually, we already discussed about this, but never mind, we're going to take a look at that. Next is mitigate ARP attack. ARP attack actually when a user requests a translation from IP address to like to know a MAC address. But what happened actually for a switch, whenever they receive incoming message from certain MAC address, so they will record inside their MAC address table. So at the same time, their table will be flooded with 100 or 1,000 of MAC address from certain port. So we would like to prevent this by mitigate ARP attack. And lastly is actually mitigate STP attack. There's another spanning tree protocol. An attacker can connect to a user port, actually a port that should be reserved for user, but they connect a switch and then they introduce a new spanning tree. Okay, we go to our first topic, 11.1, implement port security. So what we like to achieve here is actually to secure unused port. So it's important for us to remove all the unused port, which is we know this port should not be used by any means. There is no user at that point. So we are going to take it down. So how to do that? We just go to the interface, or we can do by a range. Interface range fastnet/1-10. So we are not going to use that interface. So press enter. After that, you are in the sub configuration for a range of interface. Then you can go with the command shutdown. Later, if you like to use that port, I mean there is a user that should be connected to that port, we can issue no shutdown. Okay, after that, mitigate MAC address attack. Okay, MAC address attack also can be coming from the ARP attack. So in order to mitigate MAC address attack, we can manually configure MAC address for a specific port, or we can allow a switch to learn for certain number of MAC address only. So we are not going to receive as many as MAC address from one port. So if there is a violation, I mean we already configure this port actually should be coming from this room. So there are only one user at that room. They are using this machine with this specific MAC address. So if there is change in the MAC address that for the message that coming from that port, so they are going to invoke our violation. Or we can permit certain like 4 MAC address dynamically. So we don't care about their specific MAC address, but they will learn dynamically. If more than 4, so they issue a violation. Okay, this is how we are going to enable port security. Okay, port security can be configured on every interface. Okay, to enable port security, we just use the command switch port security. But in order to issue this command, that switch port or that port must be in either mode access or mode trunk. It cannot be done when the port in the auto negotiate or in the auto mode. So please make sure You issue switch port more access if this port are meant to connect it to the user, and then introduce switch port security. After we do switch port security, we can do all the options that we discussed before. Okay. Like if you can verify with the show port security interface. Okay, we only one command that we issue before, switch port security. That's all. So you are already introduced port security. With that, we are allowed only one MAC address only, and the default violation is a shutdown. If you can see here, it will be shut down. Actually, there are many other options that we can configure with the port security. But first, we try to take a look what the default command or what the default option that we have. Okay, if we do show port security interface for specific interface that we picked before, you should see this message. Okay, port security enable, which means we already issue switch port security, and port security status is secure shutdown. For violation mode shutdown, this is a default violation mode. If there is a violation mode, violation happens, so it will be shut down this port. After the shutdown, the port cannot be used by a user. So in order to revert back, a technical person or switch operator must go to the interface and do command no shutdown. And maximum MAC address by default is 1. So for one user only or for one device. If they change the device, automatically there is a violation and then will be shut down. But we can change all of this. Okay, you can do the command switch port space port security space and put a question mark. So there are several options you can do. First, aging. You can set the age of the learning MAC address. Okay, MAC address. We can manually specify a MAC address for this port. I mean for certain port. Interface FA0/1, they supposedly to be connected from a one device only with this MAC address. Or you can set a dynamically learn. Okay, and maximum MAC address. When we put a maximum, which means they supposed to learn dynamically. When they learn dynamically, so how many MAC address they can learn. And violation. We can change the violation. Before this, a default is a shutdown. Or maximum is default is a 1. Maximum MAC address is a 1, but we can change up to 4 or whatever number that you like. For violation, there is a certain list of violation mode. For a limit of MAC address, you can do a maximum. Switch port security maximum. Okay, remember maximum by default is 1, but we can change. You doesn't need to do switch port security maximum 1 because the default value is 1. It's enough by issuing switch port security. By default is maximum 1. But if you like to change, you can turn it into, you can specify the other value. So you can see here from the info here, this is, I'm not sure from which iOS and which device. The maximum can be from 1 to 8,192. I'm sure you don't want 8,192. Maybe you would like to limit to 3 or 4 only. You can also specify the MAC address manually by command switch port space port security space MAC address space and specify the MAC address. So which means we are only allowed for this specific MAC address only. In case the default maximum is 1. But if you set the maximum is 4, so which means you already occupy one MAC address for this, one entry for this MAC address. So your switch can learn for the other 3. So there are 2 options for learn. How they should learn? Okay, they can learn dynamically, which means the switch will accept any MAC address, incoming MAC address, up to the maximum number, and they will flush that MAC address after the switch reboot. But you can also learn, the learning that MAC address and then they save them by using a command sticky. Switch port security MAC address space sticky. which means whatever MAC address they receive, they will put inside their NVRAM, inside their running config. So if you save running config into startup config, so that MAC address will be there forever until you remove it. Okay, this is an example how we configure a MAC address. Okay, by this you can see from the command here, switch 1 interface FA01. So which means we are going to configure for port FA01. So before we do switch port security, we must change the mode access. Okay, switch port space mode space access, and then we can do switch port security. Again, I would like to set the maximum number of MAC address can be connected to this port as 4. So switch port space port security space maximum 4. And I already have one MAC address that I know should be used in here. So this will be a permanent device. Switch port space port security space MAC address and put their MAC address. Okay, in this case AAA.BBB.1234. Of course, this is not a real MAC address, just an example. And then I would like to save all the other MAC address, which means there are 3 more MAC address they can learn. So we are going to use switch port security MAC address sticky, which means the 3 other MAC address, once they learn this 3 MAC address, they will save it. So there is no other MAC address or no other device can be used in this port. But how can we remove the learned MAC address? Let's say we already configure our port security that's supposed to learn 4 MAC address, but after certain period of time, these 4 devices already disconnected from the network, and then we would like to introduce a new device. So we can use a agent. Agent will be remove their MAC address entry after certain period of time based on our configuration. We have 2 configuration, either absolute or inactivity. Absolute, which means after certain period of time that they learn this MAC address, after the time is done, let's say you absolutely set 120 minutes. After 120 minutes, they will remove from our configuration and then they will learn again. So if the same device already connected, then they will learn the same device. But if the device already been removed from the network, and then they will open for a new device, which means they can learn a new MAC address. For the inactivity, as long as the device is connected, so they will not count down their aging. So the aging will be count down or will be calculated once the device have no activity, which means even in the real environment, you should remove the device from network and then there is no activity. A modern operating system will always sending and receive some message. Okay, even though the user are not sending any message. So there must be an activity. But when you remove the network, so there is no activity, so they will start the countdown. How many minutes that you put for the inactivity. So after they pass that time, so they can open for a new MAC address. So you can connect a new device. So how to use port security agent? Okay, the command for port security agent actually switch port space port security space agent. And then there is option for agent. Either to do a static, to do a time or type. Okay, for a static which means you would like to put agent for a MAC address that manually enter. You configure that MAC address manually. Okay, and then you must do another command switch port space port security space agent and pick up another option time. So in time here you must put the time in minute. How many minutes you would like the agent will be. So you can do, let's say 2 hours, you must put 120 minutes. Okay, there is another option which means you must do after that switch port space port security space agent space and type. You must specify the type. Follow after type, you must put either absolute or inactivity. So the example actually in here for the interface FA0/1, you do switch port space port security space agent space time space 10. Which means the agent time is 10. You can see here after you do show port security interface. Okay, and then you follow by switch port security agent type inactivity. So agent type, when you do show port security interface, the agent type will be type of inactivity. Okay, now for a violation. So option for violation, we have 3 type of violation, either shut down, or restrict, or protect. So what's the difference between both of them? I mean, 3 of them. Okay, by default, the port security violation is a shutdown. So you can change to restrict or protect. So actually, if you like to use shutdown, you doesn't need to issue the command switch port security violation shutdown. So this command we will never put inside your running config or startup config, or default command will not listed inside startup config or running config. So you can do switch port security violation, restrict or protect. But if you like to remove restrict or protect, you can do no switch port security violation restrict, and then we go to shutdown. Actually, you can also do switch port security violation shutdown. We remove a restrict or protect that you configure before. So let's see what's the difference between all of them. For a shutdown, for any violation that happen, that port will be turned into shutdown state. So no device will be able to use to send or receive the data. So in order to enable back, administrator must re-enable by do the command shutdown and no shutdown. Not only no shutdown, you must do command shutdown first and then no shutdown. So what happens when there is a violation? Switch will send a syslog message. If you already configure one syslog server, so they will send that message to syslog server. Okay, for a restrict, the port will not be shut down, but it will drop any packet that received from that MAC address. Which means if we are already configured a learn certain MAC address and there is a new device connected to that port, so all the incoming data will be dropped. And they also will generate a syslog message, same like a shutdown. But there is a less secure. I mean, it's not regarding a secure, but regarding the processing. When you do a restrict, they will generate a syslog message. So your switch will do a lot of process. Still need to process a syslog message. But with a protect, they do the same thing, withdraw all the packet, but will not generate any syslog message. So you are not burden your switch processor in order to generate a syslog message. So it's up to you either to select anyone. But the result actually almost the same. All the data cannot be sent. But with the shutdown, you do enforce a shutdown. So no any device can be used after that. For restrict and protected, when you remove unauthorized MAC address, a device with unknown MAC address, and you plug in the original device, and that original device that the switch already learned the MAC address can be used straight away, can be used back. But for shutdown, it cannot be used until administrator re-enable it. So this is the example how to configure a violation. Interface FA0/1 switch port security violation restrict. So if you choose restrict, you should see it highlighted violation mode as a restrict in here. Okay, so whenever there is a violation, a switch will pop up a message. So this is an example of violation message. PM4 error disable, and I would like to show here line protocol interface FA0/18 change state to down, which means the violation mode is a shutdown. So you can do show interface FA0/11. So you see fastnet 18 actually is down, line protocol is down, but in bracket error disable, and there is some other message. Okay, so in order to re-enable, administrator must go to interface FA0/18, must issue shutdown first and then no shutdown. So if you do show port security interface when there are in the violation mode, so you can see violation mode is a shutdown. Okay, you can also verify a port security by issue command show port security. it will list all the port that you configure with port security and all the MAC address that they learn. Okay, current MAC address, how many that they learn, and current address, maximum by default is 1, and they learn now they are not connected to anyone, and any security violation. So they have a statistic for this. So let's say we do for specific interface, show port security interface FA0/18. So you should see if there is a security violation count and so on. Okay. You can also verify with a show run, and you can filter with the command begin whatever interface that you would like to verify. So let's see for this interface FA0/19. Switch port mode access, switch port security, switch port security maximum 10. You can see the line is not so organized, but that's okay. As long as switch port mode access on the top. Okay, after that, switch port security MAC address sticky, and switch port security MAC address sticky, one that you put manually. Okay, to display all secure MAC address. Okay, to verify, to view all the MAC address that they learn, you can do show port security address, and you can see for each port FA018, FA019, what is the MAC address that they learn. You can also do show MAC address table. Show MAC address table actually the current device that connected. It can be flagged, but inside port security address, it will be there forever if you do a sticky. So we have the experiment 11.1.10 through a packet tracer. So we are going to configure our port security, and then we are going to play around with the violation mode. So if we remove a current device, so let's say PC1 and PC2 with their own MAC address, so the switch will learn then MAC address. So let's say we learn then through manually or through dynamically learn sticky. And then after that, we remove the cable and we plug it into Roche laptop, which is have a different MAC address. So our switch, we apply a violation mode. So let's say we do not configure anything, so we do a shutdown. And then after that, we connect back to original device. That port will not be able to be used because they already shut down. Administrator need to re-enable it. But if we are configured as a restrict or protect, once we connect to a Roche laptop, so the port will not accept any incoming message. We drop all the message. But if we remove Roche laptop and connect back to the original device, the original device can use back that port straight away. That's the difference between shutdown and without a shutdown. Okay, so we are going to do our next topic 11.2, mitigate VLAN attack. So there are VLAN hopping attack, which is a hacker or attacker try to learn from our VLAN. So they are trying to spoof dynamic trunking protocol. So for all the port that's supposed to be connected to a user, please remove mode auto. Put them in the mode access, so they cannot do any DTP message. They cannot spoof any DTP message. So this is how to mitigate. So very easy. Disable DTP trunking on non-trunking port, which is the access mode. When you do switch port mode access, automatically you disable a DTP. But for a trunk mode, they are still able to use a auto negotiate. If there is other device that are connected to our switch that with a trunk, so that device in the auto, they will auto negotiate. So how to prevent auto negotiate? So on our switch, we remove auto negotiate with the command switch port non-negotiate. So if attacker connect to our trunk port, so their port will not receive any info regarding our trunking configuration. So they can learn from that info actually. And the other thing actually, to use native VLAN. Okay, by default, a native VLAN is VLAN 1. So if they are connected to any switch, by default, they are in the VLAN 1. So they will be able to send and receive a data without VLAN. I mean, without a tagging for VLAN, because VLAN 1 is a native. So the switch will not put a tagging. So we are supposed to create another VLAN. Sometimes we call them as a black hole, which is we are not going to connect to any network, any user. Okay, so we do switch port trans native VLAN and create some VLAN that we do not use. 11.3 mitigate DHCP attack. Actually, we already discussed regarding DHCP attack. So a user or an attacker can exhaust our DHCP server, can starve our DHCP server, which means if we reserve 100 IP on our DHCP server, so the attacker will request all the IP be reserved for them. So they ask for one IP, and then DHCP server allocate the IP. Then they ask for another IP. So until the time is expired or they flush that, so a legit user cannot request any IP. So in order to do that, we must enable DHCP snooping on trusted port. Okay, how to do that? Okay, I go straight to the command. Okay, enable DHCP snooping on the global configuration with the command IP DHCP snooping, and then on the trusted port, which means a connection between device, which means from our switch to a router to a DHCP server. So we do IP DHCP snooping trust. So we don't want to filter any DHCP message there, because a message coming from the DHCP server, we don't want to filter out. But a message coming from a user on untrusted interface, that user might run an attack. So we would like to limit a packet per second by the command IP space DHCP space snooping space limit space rate, and put a number a packet per second. Okay, actually we can put 4, 5 or 6. Okay, should be enough. For 1 second, they should not request more than 6 times. Actually, it's already fast. You can reduce that again. So you enable this command inside the interface. And then after that, we do IP DHCP snooping in the VLAN global configuration. On the global configuration, you do IP DHCP snooping and specify the VLAN number. So let's take an example. Okay, in this diagram, switch 1 connected to the DHCP server. So for the fastnet 0/1, we consider this is a trusted port because it's connected to the DHCP server. So any message regarding DHCP, we don't want to filter because it's gonna disrupt other message from the other device. Let's say there are 100 of users here. Of course, there will be 100 of message go through here for 1 second. But it can be one message per second is from one user. So all the port connected to user, we set them as a untrusted port. But for the example, we are only deploy only one port only. So the command we do for switch 1, the IP DHCP snooping on global configuration, and then on interface FA0/1, we do IP DHCP snooping trust. That's all. And on all other port, let's say FA0/5 up to 24. That's 24. By using command interface space range FA0/5-24, we'll do IP DHCP snooping, limit, rate, and then number. Let's say 6 frame, 6 packet for minute. Okay, done. And then we enable on what interface, what VLAN that we would like to use this snooping. So IP DHCP snooping VLAN, list all the VLAN with a comma or by a dash for range. That's all for enabling DHCP snooping. So after we already configured DHCP snooping, we can verify with the command show IP DHCP snooping. So you should see all this here. And on the binding, you can show IP DHCP snooping binding for any message that has been sent. okay, for DHCP request. Okay, next 11.4, mitigate ARP attack. Okay, an ARP attack actually, attacker or threat actor here send unsolicited ARP reply, which means they reply. Actually, this is not a real reply, but a crafted reply. So they reply, okay, this IP address actually use this MAC address, or this MAC address actually have my IP address. Okay, and then all actually are crafted, send all to the switch. So when the switch receive that message, and that ARP request actually mean for the other device. But when the switch receive, switch will record inside their MAC address table. And after certain period of time, the MAC address table will be full. And then we flush down all the entry, which is the legit entry. So we would like to prevent that by also enabling through DHCP snooping. But we add for ARP inspection. So in order to do ARP inspection, we must configure DHCP snooping like before, globally, and then put a trust on port that connected to our device, and then create a DHCP snooping on each interface and each VLAN, and then we enable dynamic ARP inspection on all the ports. So we already do IP DHCP snooping, VLAN, and all the port, and then we must do IP DHCP snooping inspection trust. Okay, this is for Fastnet 24 actually for the trust, but for a device. Okay, to configure them, we are only configure on the port that connected to a DHCP. So we are going to do IP ARP inspection trust. But there are many options you can configure, either based on MAC address, destination MAC address, source MAC address, and the IP address. So you would like to validate through a MAC address. So what MAC address? Source MAC address, you can put src-MAC address, or you would like to validate based on destination address. So IP ARP inspection validate destination MAC, or you would like to validate based on IP. You can do IP ARP inspection validate IP. So in this example, if you do show run, after that include validate, you only have one entry only, which is the last entry, which means you are only able to do one line of command only. So if you like to include multiple inspection like source MAC and destination MAC or plus IP, you must put inside one line command, just like IP ARP inspection validate src-MAC space dst-MAC space IP, or any combination that you would like to use. 11.5, mitigate spanning tree protocol attack. So spanning tree protocol attack can be happen. Spanning tree actually mean for connection between switch and switch, but a switch also can send a spanning tree message BPDU to all port, also for a device, I mean the end device, PC and so on. So in order to prevent an attack can be coming from the user side. So a user will connect a new switch into their user port. So they will send a BPDU, indicate there is another switch, so please build up a new spanning tree protocol. So that bogus switch might be introduce a new switch port. Let's say they would like to take our switch port. So we don't want this to happen. So in order to prevent that, we can block any BPDU from the user side. So attacker cannot introduce a new switch into our spanning tree. So in order to do that, we can introduce port fast or BPDU guard in our port. Okay. So how to do that? Interface FA0/1 switch port mode access spanning -3 space port fast. So you already enable port fast. Or you can configure globally spanning tree port fast default not inside the interface, but inside the global configuration. So it will be enabled on all ports. I mean all ports that connected to user. Okay, you can verify by show running config or show span3 summary. Okay, for BPDU guard, okay, inside the interface, let's say you already do a switch port mode access, and then span3 space BPDU guard space enable. Or you can configure globally through span3 port fast BPDU guard default. Okay. So that's all regarding a switch security configuration. So we have a experiment regarding all those mitigation that we would like to do. Okay, this experiment can only be done through a packet tracer. It's not, it cannot be done in the real device, but it requires so many devices. So we are going to use a packet tracer. Okay, to secure unused port. Okay, mitigate VLAN hopping attack, mitigate DHCP attack, mitigate ARP attack, and mitigate span3 protocol attack. So you must follow all of them in here. So, and then after that, you can verify by introduce the attack, like a span3 attack, span3 protocol, okay, by putting a switch here, and then you declare as a new root port. Either they will recreate a new span3 or not, okay. But there is also a physical experiment can be done in our lab, but of course you cannot come into the lab, but you might see what we want to do here. So actually we are not going to do this because what we do in 11.6.1 already cover everything. Compared to 11.6.2, it's just 2 switch and 2 PC only. But it try to do all of them. So that's all. Thank you.